For the second part of section 4. Now, what we focused on primarily on Thursday was when you're dealing with an exponential with a variable stuck in the exponent and getting that out of there. The reverse of that concept is when you have the variable inside of the logarithm and you need to pull the value out. But the process works the same way. Just the reverse. Like here you have logarithmic, so change it to what?
E to the 2/3 equals x.
Yep. Your base is log base e, so e to the 2/3 is equal to x. Okay. For part B, what can you do there?
Get rid of the log base 4.
What property allows you to do that?
1-to-1.
1-to-1. So because I have that on both sides and nothing else going on, I can just throw those out entirely and set what's left equal. So then when I go to solve this, what would I do next?
Add x, subtract 2.
Yep. Add the x, subtract the 2. So I'm going to get 4x and x is equal to? X is equal to 1.
Wait, is this 3/5?
No, this is the second part of 3-4.
Oh.
Thursday we did about the first half of it. Today we're doing the second half of it.
Oh,
Then 3-5. Tomorrow I'll teach all of 3-5. And then you'll have basically Wednesday and Thursday as review. And then test on Friday. Okay. So, for this one, what would I do?
Can you get rid of log base 3?
No. Because the problem is the 1-to-1 necessitates having a single log on each side. If you have multiple logs, you can't just peel them out of there. Okay? So I need to somehow consolidate those two logarithms into one.
Yeah, you just put.
Can you do log base 3 of 5x plus 13/6?
Exactly. You can put those together.
Then you can get rid of log base 3.
Then you can use 1-to-1 to get rid of log base 3. Because it's minus in between, I can take log base 3 of 5x plus 13 divided by the 6 is still equal to log base 3 of 3x. Now you can take what's inside. 5x plus 13 over 6 is equal to 3x. Then what? Yep. So you have 5x plus 13 is equal to 18x. Subtract 5x. X is equal to 1. Questions on those? Good. I like to think of this chapter as the calm before the storm.
This is chapter 3. I thought chapter 5 is working out.
Well, 4, 5, and 6 are trig. So it's all kind of builds. Example 7 here looks at something a little more complex, but it still breaks down to the same thing. You're still trying to solve for x. So what would I do first?
Move the x over. Or 6.
Move the 6 over. So 3 ln of x is equal to? Negative 2. Then? Divide by 3. ln of x is negative 2/3. Then? E to the negative 2/3 equals x. Now if you're really not comfortable just doing that straight transformation from logarithmic to exponential, that's fine. You can also just move both things into the exponent like that with your base. Because what's e to the ln of x? X. And you get e to the negative 2/3. If you're comfortable just jumping from one to the other and back, that's great. It, in my opinion, goes faster. You can just raise both sides into the exponent of whatever that common base is, or whatever your base is that you're using. It does work. For that then, it does ask for round to 3 decimals, so when I approximate it, I get what? Probably. .513. All right. Skip that one. That's the same old. Look at this one. Log base 10 of x plus log base 10 of x minus 9 is equal to 1. What do I do first?
Consolidate into a single log.
Yep. Combine them into a single log.
X squared plus negative 9x.
Not plus.
2x.
Oh, wait. I misheard what you said. X squared plus negative 9x.
Yeah,
Sorry, you were mumbling.
negative 9x.
Why did you say plus then? Minus 9x, yes. X squared minus 9x is equal to 1. Then
1
you could, well, 1 to 1, not directly. You can get to 1 to 1 if you change 1 so it has a log in it.
Yeah, no, we're just gonna do 10 to the first. It's just 10.
Log base 10.
Say again? You can do that, change it to exponential, yep. So that's going to be what?
10 equals x squared minus 9.
Yeah, you have 10 to the first is equal to x squared minus 9x.
Move the 10 over, and then just do some quad.
Move the 10 over. I honestly wouldn't bother because this one does factor fairly easily. What's that factor into? X minus 10, x plus 1. So then what do you get for solutions?
10 and negative 1.
Nope. Why just 10? Yeah, you got to go back to your initial logarithms. Because this is log base 10 of x here, this negative 1, can you tend to anything? Will that ever be a negative? No. Therefore, this one doesn't work, only this one does. You will have some cases where neither of them work. You will have some cases where one works but not the other. Or they might both work. You have to check your answers when we start getting into these. Okay? Questions on that one? Okay. For this, you have deposited $1,000 in an account that pays 6.25% interest compounded continuously. How long will it take your money to double? Where should I start? Say again?
EERT formula.
Yeah, the PERT formula. A is equal to P times E to the RT.
What did you say it was?
PERT? That's what the word is.
It is.
You never heard that before?
I think it's just funny. It's just fun.
Okay.
So it'd be 1,000 e to the 0.0625. And then we would double, so it'd be 2a. Or no. Yeah. 2,000.
2,000. If we put in 1,000 over here, we have to put 2,000 over here. Technically, though, your first step's going to be to do what? If I,
Oh, right, because you just made $2,000.
well, if I want to, you only made 1,000. You had to put 1,000 in. Anyway,
You have $2,000 now, so go harder.
so the t here is what I'm trying to solve for, right? So what would be my first step algebraically?
You had to go up.
Well, my first step
First.
would be what?
Divide
Divide by 1,000. Get rid of the coefficient first. You want to get the base by itself, right? Raised to the power. Divide by 1,000 is going to give me 2 equals e to the 0.0625t. Now, honestly, with this kind of problem, do I even need to know the $1,000?
No?
No, because it doesn't matter if you have $1,000 in there, $10,000, $40,000, whatever. You could also just have $1, because all you're looking for is the amount of time to double. Okay, so you can just put whatever your multiplier is over here. If it's triple, put a 3 there. If it's quadruple, put a 4, so on and so forth. Doesn't matter what your initial value is. You don't need it. Either way, though, then when I go to solve this, what am I going to do? Yeah, I would change it to logarithmic. So what would that end up looking like? What's your base?
E.
E. So natural log of what
2.
is equal to?
0.
Does that make sense? You could also, up at this point, take natural log of both sides. You get the exact same thing. When you do this, then, what's next?
Divide by the really small number.
Yeah, divide by that. So ln of 2 divided by 0.0625 is equal to t. How many years will it take?
11.9.
Wow. Wow.
So 11 years to double. All right.
In the grand scheme of things, it's not too bad.
6.5, yeah, 6.25% interest isn't great. Good thing is those that compound continuously, the credit card companies on you, are usually closer, somewhere minimum 13, 14%, some of 80%. So they get money from you a lot quicker.
Yeah, something else.
Eh? That's how they make money. For this, the number Y of endangered animal species on a protected wildlife reserve from 1990 to 2004 can be modeled by that logarithmic equation. During which year did the number of endangered animal species reach 342? Yeah, 342 is going to be your Y value. 342 is equal to the rest of it. Then what?
Move the 117
Add 117 to both sides. You're going to get what on the left?
459.
459.
Divide by 159.
Okay, now at this point, make sure, I don't type this into a calculator yet. I wait until after I get everything down there, so you don't have rounding errors as much. But those are gone, so you have ln of t is equal to that 459 over 159. Then what?
Change the exponential.
Change the exponential. What's your base?
E.
Raised to the
459 over 1.
equals t. That type into your calculator, you get what?
17.933. Yeah, 17.935.
Okay.
936.
You just want to round that up to 18s, talking about years.
But it says during which year.
Oh.
So would you want to round it?
No.
No. And the question is, what during which year would that be?
Add 17 to
19 what?
97.
1997. It says t equals 10 is 1990, right?
Oh, I didn't read that.
So 17 years from 1980, in other words, we're 7 years after there, would be 1997. When in 1997? Yeah, so late 1997, somewhere in there. Questions on any of it? Say again? I probably would. If you want to, you could actually narrow it down to the day if you were really ambitious.
Let's go. Quiz.
Just take that times 365.